Hey, everybody. Still working on the sound. I hope you guys can hear it. All right, so let me reiterate. You need to make sure you're reading as we go along this. You need to make sure that you're either writing the notes if that helps you, or you are really reading and going over these notes. I mean, I can't be there to help you. Make sure you write them or something, but usually, for most people, writing them helps them remember. So this is section 2, speed and velocity. I'm going to have to do a lot of math on this one. So you might, I'm probably going to have to do a different video after this. Okay, let's see how far we get. This one's about speed and velocity. So these are all math problems. They're all basic algebra back in September or August. Okay. So this is speed, and the definition for speed is it's the ratio of the distance an object moves to the amount of time the object moves. The SI unit for speed is usually meters per second, which is m/s, meters per second, because we're SI. However, you have to use the appropriate distance. If I'm trying to tell you the distance from my house to school, I'm not going to use meters per second. I'm going to use kilometers per hour. And if we're being honest, I'd use miles per hour, right? Miles per hour is written as this, mph. Kilometers per hour is this. Make sure you write it like this if you're doing miles, and kilometers like this. If not, this could be meters per hour or something, but this is miles per hour, kilometers per hour. Okay. There are two ways to express the speed of an object, either average speed or instantaneous speed. Average speed is computed for the entire duration of the trip. This includes bathroom breaks. This is everything. This is like the entire trip from start to finish, even when you stop at Chick-fil-A for food or the rest area to go to the bathroom. Okay? Average speed. The next one is instantaneous speed. This is measured at a particular instant, like right then when the cop puts the radar gun on you and says you're going 75 miles an hour in a 50, that's the instantaneous speed. Okay, so average speed is the total distance divided by the total time it takes for you to travel that distance. So the formula for that is speed equals distance divided by time. This right here is usually the average. Average speed and speed are the same thing, okay? You're always going to figure out average speed no matter what. When you figure out speed or average speed, same thing. You always figure out the average speed. So it's total distance divided by total time. So S speed equals D distance divided by time. Instantaneous speed is the rate at which an object is moving at a given moment in time. This is your speedometer or a radar gun. This does not mean speedometer. This is speedometer, okay? That gives you your instantaneous time. Or the radar gun with the cop who pulls you over, okay? So you have your average speed, which includes the entire trip, okay, even bathroom breaks and stuff, or the instantaneous speed, which is at that instant, at that instant. Okay, so here's one problem. I'm going to try to do this without my cam, but I will probably go ahead and do it again. In fact, let me go ahead and do that, and I'll put a let me skip this. I'll make you a video, and then I'll come back to it, and let's go back down here to graphing motion. Hopefully you also looked at my displacement video, and hopefully that helped you also. The little questions that I'm giving you every day, if you get one or two wrong, it's no big deal, guys. It's okay. They count for nothing, hardly. They're just a way for me to make sure that you're doing it and you're showing up to class every day. All right, so the next one is, I'll come back to the problems. The next one is graphing motion. So the distance time graph is a good way to measure motion. The distance time graph is measuring speed, okay? So slope is the change in the distance divided by the time, which is speed, okay? And you need to go look on page 334 and look at the graphs because they will be on your test, okay? Velocity, it's another word, and in this class we'll use velocity and speed interchangeably, okay? The velocity, because there is no formula for velocity. Velocity just includes a direction. So it's a vector because it has a direction and a magnitude. So velocity is the speed and direction in which the object is moving. So I would say 4 miles per hour north. That's velocity. Speed and direction. 75 kilometers per hour east. Okay, so velocity is a description of both the speed and direction of the motion, and velocity is a vector because it has speed or a quantity and a magnitude, or a direction, sorry. Magnitude is a speed. The change in velocity can be the result of a change in speed, a change in direction, or both. The change in speed would be slowing down, speeding up. A change in direction would be going right or left. And then sometimes you have to turn on roads. So sometimes when you turn, you should slow down. And then you have to change direction. So that's both. Okay? So on here, I have a racetrack with Dale Earnhardt. He's a racer. Okay? And so I'll show you that on the speed video. Okay? And how that is. And then let's talk about combining velocities. All right, so the way you can change your velocity is you can either speed up, slow down, change in speed, change your direction, okay, north, south, east, or west, or you can do both. You can slow down when you turn, you can speed up when you stop turning, like when you go straight again. So that's how it means, okay? Combining velocities. Sometimes the motion of an object involves more than one velocity, okay? 2 or more velocities add by vector addition, and this is on page 337. This is, I think there's boats on the picture. Look at that, and I'll try to go over it again. I'm going to go ahead and get off now, and I will send you a video on the math problems and changing in velocity. Okay? All right, bye.